Hi everyone, my name is Catherine St. Gabriel. My topic for this week was stress, strain, and modulus of elasticity. To begin with, I want to talk about deformation, which is a change in shape due to the application of a force. Even very small amounts of forces are known to cause some deformation, and deformation is experienced by objects or physical media under the action of external forces. Some examples of that would be squashing, squeezing, ripping, twisting, shearing. And thus, the two terms that describes the forces on objects undergoing deformation are stress and strain. And if you take a look at the photo before deformation, there's nothing going on with the object. But then after deformation, you can see that there's a certain change, the way that it's curved. And then next up is stress, which stress is the quantity that describes the magnitude of forces that causes deformation. Stress is generally defined as a force per unit area, and the SI unit for it is Pascal or PA. And the more common types of stress are compressive and tensile stress. And when a force pulls an object and causes elongation, that is what we call tensile stress. An example of that would be an elastic band. And a force that causes compression on an object, that would be called compressive stress. Of course, there are also going to be situations where the force is neither compressive or tensile, but there's still a noticeable deformation that goes on such if you grab a textbook and with your left hand you press and pull away from you, while with your right hand you press and pull towards you, and that would be an example of shear stress. And then strain. Strain is the measure material's response to stress. It's given in a fractional change, which can either be length, volume, and geometry, and therefore strain is a dimensionless number. And the greater the stress, the greater the strain. However, the relationship between stress and strain does not have to be linear. And you can see that more if you look at it graph-wise. And then Young modulus defines the relationship between normal stress and lateral strain. And the modulus of elasticity is basically the proportionality constant in linear relation between stress, strain, and that is also going to be an SI Pascal. In limits of low stress values, the general relation between all three is stress equals elastic modulus times strain. And it has the same unit of stress because strain, as I mentioned before, is a dimensionless number. And when an object is characterized by large values of elastic modulus, the effective stress is small and vice versa. And I just put an example of certain materials and their Young modulus. As you can see, steel would be 2.0 times 10 to the 11th. And to continue, the elastic modulus for tensile stress is called the Young modulus. So if you're looking for tensile stress, it would be called the Young modulus. And then bulk stress is known as the bulk modulus. And shear stress is called the shear modulus, but it's also known as the modulus of rigidity. And that just measures the ratio of shear stress to the angle of deformation. And the elastic modulus for various materials are measured under various physical conditions, such as varied temperature and collected engineered data tables for reference. And a lot of this is basically used by engineers and construction. And there's more examples of materials and their elastic modulus. And then next up is tensile and compressive stress. So tension and compression occur when two anti-parallel forces of equal magnitude act on an object along only one of its dimensions, such in a way that the object does not move. Tensile stress and strain occur when the forces are searching an object, causing its elongation, and the length change delta L is going to be positive. While with compressive stress and strain, when that occurs, the forces are contracting on an object, causing it to be shortened, and the length change delta L is negative. Tensile stress equals F over A, which F is a force acting perpendicular to the surface, and A just equals area. And then tensile strain is delta L divided by LO. And LO is the original length, while delta L is the length change. And if you take a look at the photo, as you can see, with compressive stress, the arrows on the outside are going outwards, while the arrows on the inside are going towards each other. And then for tensile stress, it's the opposite. The forces are going towards each other on the outside, and then the forces are going away from each other on the inside. And then next up is bulk stress. And bulk stress is caused by the compressive force that is felt in all directions. An example would be like if you dive into the water and feel all the forces in all directions, that is bulk stress, or you can call it pressure. And bulk stress always tends to decrease the volume enclosed by the surface of a submerged object. And when bulk stress increases, the bulk strain increases in response. And you can kind of see this based on the example I have given. There's force and pressure going all around the object. And this is all the information I have. Thank you for watching, and I hope everybody has a good week.